Hello, my name is Caitlin Fung, and I'm a junior at UMass Amherst studying chemical engineering. I will be presenting my project on wind energy patent analysis. To begin, the motivation of this project is to utilize patents to forecast the cost of offshore wind energy. Offshore wind energy is a high potential resource that can provide decarbonized electricity to the grid, which lessens the dependence on fossil fuels and mitigates the effects of climate change. Experts believe that the cost of wind energy will dramatically decrease from today's standards by the year 2050, making it a cost-effective solution. Although expert projections are informed by their research, it is still possible that their forecasts err on the side of caution by having a more conservative estimate. Additionally, experts may have varying opinions on how these costs will change, in which patents can help lessen this discrepancy by providing a scope for the technological progression of wind energy that can be used to inform cost models. So what is a patent? A patent is an exclusive right granted for an invention by a national patent office or a regional office. When an inventor files a patent application, they must describe the title of the invention and indicate its technical field by including a background and description. The abstract contains a brief summary of the invention and their claims define the matter for where they seek protection in their patent. After the patent is filed, examiners assign each patent with a corresponding code that describes the function of the invention, and a patent can be associated with multiple codes. This process is done in a fairly non-transparent manner, which does not allow us to know how accurate these assignments really are. We hypothesize that if these assignments are incorrect, then it could result in a large difference when searching for wind energy patents. There are two wind energy classification codes, FO3D, which represents wind motors, and YO2E10-7, which represents wind energy. We know from completing a preliminary patent review that a significant amount of wind energy-related patents were labeled with FO3D, but not YO2E10-7. Therefore, by grouping these two codes, they capture wind energy patents based on the existing standards. For the purposes of this presentation, these two codes will be referred to as the conventional classification codes. This leads us to the goal of this project, which is to improve the wind energy domain within a patent dataset aside from just using the conventional codes. The data resource that we use for this project is PatStat, which is the European Patent Office's worldwide patent statistical database. It has over 105 million patent applications that span over 80 countries. SQL, structured query language, was used to communicate with the database to retrieve specific data or content. Our first task was to evaluate how many patents with the conventional codes fit into the true wind energy domain within the dataset. We completed this by reviewing 100 random patents with the conventional codes and labeling them as whether they were yes, related to wind energy, or no, not related to wind energy. Some examples of the patents that were reviewed are shown here. The example on the top is a patent that was labeled as yes, related to wind energy. It is an invention that analyzes the vibrational characteristics of a wind turbine blade. The example on the bottom was labeled as being not related to wind energy. It is an invention for a windproof screen on the side of a highway bridge. After evaluating the set of 100 random patents, we found that 93% of the patents were labeled as being related to wind energy, while 7% were labeled as being not related to wind energy. Although this is a good starting point, our next step was to examine patents that do not have the conventional classification codes, but yet were still related to wind energy. We decided to append keywords to the conditions of our wind energy domain. These keywords were found in a study done in 2016 by Tsai et al., along with keyword suggestions from UMass Amherst's Wind Energy Fellows. The new keyword conditions is shown here by the purple circle. Patents were grouped within the segment if it contained a keyword within its title or abstract. After appending the keyword conditions, we wanted to closely examine these labeled segments where the patents contained a keyword but do not have the conventional codes. We estimated this by conducting a patent review that was completed by 4 Wind Energy Fellow volunteers. Each volunteer was given the same 25 overlapping patents within their sampled set, and all 4 volunteers agreed on their judgments of the overlapping set. We found from this manual review that 42% of the sampled patents were labeled as yes related to wind energy, and 58% of the sampled patents were labeled as not being related to wind energy. From these results, we gathered all the classification codes that were associated with each sampled patent, and counted the number of times each code was present within the total pool. After ordering all these codes in descending order of occurrence, we took the top 15 codes within the set of patents that were labeled as being related to wind energy and included this list of codes as a condition to our wind energy domain definition. By taking the intersection of the new code list with the keyword list, shown here in the yellow circle, our new potential wind energy domain results from the union of the yellow circle with the green circle, which represents our conventional codes. This appended 7,949 patents to the conventional code domain, shown here in this diagram as new additions. These new additions expand the conventional code domain by approximately 10%. Besides an increase in the number of patents within our wind energy domain, we next wanted to evaluate how our new patent additions compared to the patents from the conventional codes. We first compared the conventional codes and new additions by their publication year. We found that a higher percentage of our new additions were published within the past decade in comparison to the conventional codes. We also compared the application authorities between the new additions and the conventional codes. This was done by taking the top 10 application authorities within the entire PatStat dataset. For example, there's China, the US, the rest of the world, Europe, Japan, and Germany. It was found that our new additions were more heavily concentrated within patents filed from China in comparison to the conventional classification codes. Although one could argue that wind energy patent analysis could be completed within the domain of conventional codes, a more thorough analysis can be completed by also including our new additions, since these differences have the potential to significantly affect wind energy cost forecasts. Using our new additions with the conventional codes can provide a comprehensive lens of the technological progression of wind energy. I would like to thank my faculty advisor, Professor Aaron Baker, and my principal investigator, Dr. Anna Goldstein, for supporting me on this project. I would also like to thank the 4 volunteer reviewers, Jacob, Hannah, Mariana, and Samuel. Thank you so much for taking the time to watch my presentation at the Massachusetts Undergraduate Conference.